So from its constituent element. Now, what we are going to do is other definitions. The second one is standard enthalpy change of combustion. So that is standard. Standard means room temperature. Enthalpy change of combustion. So now what happens in this? The symbol is, again, the label is given to you so that you can, this is delta HC. Delta HC. So the label is assigned so that you don't have to talk about the equation. Kisi ko batana hai, so you don't have to mention the whole equation. Now, enthalpy change of combustion is where it's always exothermic. First thing, it's always, you look at the word combustion. Combustion reactions are always exothermic. So the value is always negative. Unlike enthalpy change of formation, this one is always exothermic. The other thing about this is that when you talk about combustion reaction, it's a spontaneous, remember, it's going to be a spontaneous. So not every reaction with oxygen is considered to be combustion. It's a spontaneous reaction where heat is produced and the substance burns in oxygen. So for example, the rusting of iron is also a reaction with oxygen, but it's not combustion. You can't call it combustion. So spontaneous reaction where heat is produced and substance burns in oxygen, or you can say reacts with oxygen. So so I'm going to write the definition now, which is the proper definition, because they're going to ask you for this. So it's the energy released always, and it's specifically for 1 mole of a substance. When 1 mole of a substance burns in excess oxygen. So what do we mean by excess oxygen? That it has to be a complete combustion reaction, not a half-baked or incomplete combustion reaction. It has to be, this ko underline bhi kar dete hain ki what this means is that it has to be a complete combustion reaction. So it burns in excess oxygen and measured under standard conditions. So measured under standard conditions with everything in the standard states, because if you're measuring it with everything in their standard states,
सर
yes,
अभी आपने कहा था कि वो आयरन जब ऑक्सीजन के साथ रिएक्ट करेगा तो वो कंबशन नहीं होगी, तो वो क्यों है?
नहीं, क्योंकि remember combustion is when you have a spontaneous reaction. Just for example, glucose आपकी body में ना, that's it reacts with oxygen, ठीक है, in a way, and it produces carbon dioxide and H2O. That is respiration. That is not combustion, ठीक है. Iron oxygen के साथ react करता है, that is rusting. Combustion जो image आना चाहिए ना, when you think of combustion, it's flames coming out, ठीक है. It's a spontaneous reaction where flames are coming out, where heat is produced, and when something burns in oxygen. So remember this, not any reaction, every reaction that reacts with oxygen is not called combustion. ठीक है?
Okay.
So वो glucose वाला reaction in your body, in your cells, that is respiration. That is not a combustion reaction. Rusting of iron is not a combustion reaction. ठीक है? So what you have to be careful about is enthalpy change of combustion is measured for 1 mole of a substance. That's one thing. So whenever somebody is talking about the enthalpy change of combustion, basically they're burning 1 mole of a substance. So if somebody tells you कि भाई enthalpy change of combustion of ethanol, let's say there's a table and they give you this value that the enthalpy change of combustion of ethanol is minus 200 kilojoules. It's always minus, so it's minus 200 kilojoules per mole. So how do you figure out, like, what reaction is he talking about? He's talking about that reaction. Kis reaction ki enthalpy change, which reaction's enthalpy change is given over here. So he's basically talking about that reaction where 1 mole of ethanol burns in excess oxygen and whatever it produced. I mean, you should have an idea of what is produced when a substance burns. Specifically, if an organic compound burns, it usually produces carbon dioxide and water. So it produces carbon dioxide and water, and carbon dioxide should be in gaseous state, and water would be in water is going to be in liquid state. So that is your combustion reaction. So when somebody tells you that the enthalpy change of combustion of ethanol is this value, what they basically mean is this reaction. They're talking about this reaction. So from now on, no one is going to tell you the reaction. You have to figure out the reaction on your own. They'll just tell you the enthalpy change, that the enthalpy change of combustion of something is this. So for example, ek aur kar lete hain. What if they tell you that the enthalpy change of combustion of C2 CS2 कर लेते हैं, CS2. ठीक है, that has a particular value, minus 150, some made up value, minus 150 kilojoules per mole. So which reaction is he talking about? He's talking about that reaction where 1 mole of CS2, remember this has to be 1 mole. Achha, sorry, I didn't actually balance the previous one, so we need to balance it. This at all costs has to be 1 mole. So it's going to be 2 carbon dioxides. It's going to be 6 hydrogens. So there would be 3 water molecules. That's a total of 4 plus 3, 7 oxygens. So this is 3 O2. So now it's balanced. But remember, the substance has to be 1 mole at all cost. And similarly, we can talk about enthalpy change of combustion of so we can talk about the enthalpy change of combustion of CS2. I mean, enthalpy change of combustion of CS2 is 1 mole of CS2 burns in excess oxygen and produces carbon dioxide. Carbon turns into carbon dioxide, and the sulfur would turn into sulfur dioxide. And the first one has to be 1 mole at all cost because you're burning 1 mole of the substance. So there's going to be 1 carbon dioxide and sulfur 2, so there would be 2 sulfur dioxides, and in total your oxygens would be 6. So there would be 3 O2. And you have to mention the states as well. Now for the first one, I'm going to tell you the states for this one. That's a gas. This one is also a gas. And you're measuring them under standard conditions, so all of them are going to be gases. And so one thing I'm going to tell you that you should know which substance turns into what thing. For example, if an element has carbon, remember, which is obvious that carbon would turn into, it's going to turn into carbon dioxide. Like if a compound has carbon, if the compound has hydrogen, then hydrogen burns in oxygen and produces H2O. So that would produce water molecules. And if a substance has sulfur, remember this, that it's going to burn up and it's going to produce SO2, not SO3. Making SO3 is kind of very difficult. You need catalyst for that. So during the spontaneous reaction, you usually don't get SO3. Remember what the definition of combustion is. It's the spontaneous reaction that happens. So when sulfur burns, it usually just produces SO2, not SO3. So you have to be careful about that. Let's do one more. What about the enthalpy change of combustion of अच्छा, enthalpy change of combustion of, let's say, carbon monoxide, and the value is given. Let's say it's given as minus 18 kilojoules per mole. So which reaction are we talking about? We're talking about the reaction where 1 mole of carbon monoxide is going to burn with oxygen to produce carbon dioxide. So this has to be kept as 1 mole. You have to bring in the states. So this is gas, and this one is also gas. You need to balance this. So this would be half O2. The first one has to be 1 mole at all cost. So this is the enthalpy change of combustion of carbon monoxide.
सर
हाँ जी,
ये जो एंथैल्पी चेंजेस हैं ये क्या एक तरह से इनकी बॉन्ड एनर्जीज भी हो सकती हैं?
हो सकती हैं. I mean, it is possible. Remember, it's only possible if the problem with bond energies was, I mean, you can calculate them using bond energies. ठीक है? For example, bond energies का क्या कहा था कि I told you कि bond energies can be used if the substances are all gaseous. ठीक है? For example, I think this reaction, its energy could be calculated using bond energies because all of them are gaseous. Even the previous one, you can calculate that using bond energies. Is that clear? Okay, bonds broken minus bonds formed. Clear?
हाँ, लेकिन मैं पूछ रही हूँ कि जैसे ये जो आपने लिखी है इसके लिए जो एंथैल्पी चेंज आपने लिखा है, क्या ये ही इस इक्वेशन की बॉन्ड एनर्जी होगी?
हाँ, वो मैं कह रहा हूँ कि it is possible, but kind of difficult because you're talking about a reaction जिसके अंदर there's only one bond getting broken. Only then would it be possible ना कि it's equal to the bond energy, right?
Yes.
क्योंकि वरना usually reactions में क्या होता है? It's multiple bonds getting broken and multiple bonds getting formed. So that would be kind of impossible in this particular case. ठीक है?
Okay.
There's another enthalpy change of atomization where it could be the bond energy. ठीक है? उस पे हम आते हैं तो उस पे मैं discuss कर लूंगा. ठीक है?
Okay.
अच्छा, so the thing is that this is enthalpy change of combustion. So I'll just quickly recap. 1 mole of a substance burns in oxygen to produce carbon dioxide and water. And what was enthalpy change of formation? 1 mole of a substance is formed from its constituent elements. अब दोनों के बारे में, ठीक है? Let's talk about them together. Enthalpy change of formation could be endo and exo both. ठीक है? Enthalpy change of formation of ethanol, 1 mole of a substance is formed from its elements, and the elements need to be in their standard state. Yani just state के अंदर they are present at room temperature. Enthalpy of combustion of ethanol is 1 mole of a substance burns in excess oxygen to produce carbon dioxide and water, or whatever is getting produced. If it has carbon, it will produce carbon dioxide. If it has hydrogen, it's going to produce H2O. If it's got sulfur, it's going to produce sulfur dioxide. Now, the thing is, the first thing, sometimes enthalpy change of formation can be 0. So let's add that over here. So sometimes enthalpy change of formation would be 0 and combustion can also be 0. So let's talk about formation first. When is delta HF? Remember, delta HF of elements is considered to be 0. Like if somebody tells you to find the enthalpy of formation, or you need the enthalpy of formation of, let's say, an oxygen molecule, so by definition, what was enthalpy of formation? It was that 1 mole of oxygen should be produced from what? From its constituent element, and the element must be in its standard state. So oxygen molecule is going to be produced from an oxygen molecule. So that means you're not doing anything. That means the enthalpy change would be exactly 0 because you did absolutely nothing. So enthalpy of formation is, or enthalpy of formation of oxygen is, that 1 mole of oxygen should be formed from its element, and the element must be in its standard state. So nothing happened, which is why
सर इसमें तो रिएक्शन ही नहीं हुआ होगा,
तो इसलिए वो 0 है ना. Clear है?
मतलब
So,
इसमें हुआ ही क्या है? मतलब ऑक्सीजन मॉलिक्यूल को तो कुछ हुआ ही नहीं।
तो इसीलिए ना कुछ भी नहीं हुआ, तो जीरो है। तो इंथैल्पी रिमेंबर,
अच्छा।
ठीक है। So the point is that if you sometimes when you जब हम आगे पढ़ेंगे ना, sometimes you would need the enthalpy of formation of oxygen, और आप बैठे ना, you'll be searching the table and you'll be looking for it के why, where is the, I mean ये जो ये सिंपल ही लिखा हुआ, sometimes you might need this, ठीक है, and you'll be searching for this value and you wouldn't be able to find it neither in the data booklet nor in the question, and you'll get confused. So just remember that if you're looking for enthalpy of formation of an element, that is always going to be zero. Okay, remember this, because a lot of people get confused when they're trying to solve questions. When we start solving questions using these, in a lot of formulas, they'll be looking for, I mean, you would have to input this value, like enthalpy of formation of oxygen or any element. And if you're looking for it, uh, you might get confused. So make sure, remember this, that for elements, the enthalpy change of formation is always zero, because you don't have to form them. If you form an element from its element, it's basically nothing happened. Okay, so it's zero. Clear? Is this clear for everyone?
यस।
Okay, Oswa clear? Sidra, is this clear? Ahmed clear?
Yes.
Yes.
So remember that. And then you have to remember another thing, which is that same happens to enthalpy of combustion of these things. I'll add it over here. So another point you should always remember is, so in the question, they will never tell you that. I mean, you should know this beforehand. So this one as well. Enthalpy changes of combustion of substances that have already combusted, that is also zero. So remember this, I'm just going to write this down. Enthalpy change of combustion of carbon dioxide and enthalpy change of combustion of water. And similarly, we can add enthalpy change of combustion of SO2. They are all zero. Why are they zero? Because if you try to burn carbon dioxide in oxygen, carbon dioxide is not going to burn in oxygen because it will produce just carbon dioxide. I mean, because carbon has already reacted with oxygen, so it's not going to react with more oxygen. So that's it. I mean, it doesn't, I mean, there is no reaction, nothing happens. Okay? So if you try to even burn 1 mole of carbon dioxide, you'll still get carbon dioxide at the end because carbon has already reacted. So the combustion thing is over. Now no further reaction would happen. So there is no enthalpy change. It's absolutely zero. Same goes for water. If you try to burn water, if you try to burn hydrogen, it will turn water. Oxygens will get added up. But if you try to burn water again with oxygen, nothing would happen because the reaction is already over. Okay, so remember this thing as well, that this thing over here is important. People are again looking for enthalpies. Like if you're solving a numerical question and you're trying to find enthalpy of combustion of carbon dioxide, it will never be mentioned. You have to remember this, that it is zero. Okay, ye bhi clear hai? Is this clear?
यस।
अच्छा, एक तो ये तो इन दो का याद रखना है कि so I'll just enthalpy of formation of elements is zero always. No one is going to tell you, you just have to know that. It won't be mentioned anywhere in the question. And enthalpy of combustion of carbon dioxide or enthalpy of combustion of water or SO2, that is also zero. Now, there's another thing, and that is, then there are times when you'll have multiple labels that can be assigned. So sometimes so remember this by definition, because remember, this is just a label, like enthalpy of combustion of something or enthalpy of formation of something is just a label that is given to a particular enthalpy change of a particular reaction. So sometimes a reaction's enthalpy change can have multiple labels. So be careful about that as well. So a reaction's enthalpy change can be called with different names. Okay. So all around you, you have multiple labels. Okay. You can, I mean, a single thing can have multiple different classification systems. Okay. So, so I'll give you an example first. So the example is, here's a reaction. H2 gas reacting with half oxygen gas molecule. So 1 mole of hydrogen reacts with oxygen and produces H2O liquid. As it produces, so it produces H2O in liquid state. And that's this one is a gas as well. अच्छा मुझे कोई बताया कि what would you call, I mean, it has a particular enthalpy change, this reaction. What would you call that enthalpy change? I mean, what label would you give it? Is it what? What is it? 1 mole of hydrogen burning in oxygen producing H2O. So when 1 mole of something burns in oxygen, what do you call it? Okay, that is
enthalpy change of combustion.
Combustion. So, I mean, it fulfills that criteria that it is the enthalpy change of combustion of hydrogen, because enthalpy change of combustion was by definition when its energy released when 1 mole of a substance burns in excess oxygen, that's it. So it is doing that. That 1 mole of a substance is burning is on exactly. So it is the enthalpy change of combustion of hydrogen, right? I mean, you can call that, I mean, you can, whatever the enthalpy changes, let's say I give it a value, let's say it's minus 25, some made up value. So the reaction's energy change is minus 25 kilojoules per mole. But I could have given, just like as Hans said, I could have given it another label as well. I could have called it the enthalpy change of formation of water. Why? Because 1 mole of water is getting formed from its constituent elements. The elements are oxygen and hydrogen. So by definition, the same reaction and the same enthalpy change, I can assign it a different label as well. I can call it the enthalpy change of formation of water, because 1 mole of water is getting formed from its constituent elements. So it's going to have the same exact value. There would be absolutely nothing different about these two. It's just we're giving different names to the same thing. Okay, is this clear? Emil, clear? Siddha, is this clear? Ospa? Raid, is this clear? Achha. So just, and remember, this is also something, I mean, they're going to play tricks with you. So sometimes in the reaction, you're trying to solve a numerical and you're trying to find the enthalpy change of combustion of hydrogen. And they didn't give you that. Instead, in the question somewhere, the enthalpy of formation of water is quoted as minus 25. Now, if you're not open to this, people will get confused. Like, I mean, they'll keep searching for the enthalpy of combustion of hydrogen, not realizing that it is the same thing as this thing. Okay, both things represent exactly the same reaction, and both of them represent the exact same, because it's the same reaction. The enthalpy change is exactly the same. And you can assign multiple labels to many reactions. For example, this one, carbon reacting with oxygen and producing carbon dioxide gas. So carbon is a solid and oxygen is a gas. So I can call this enthalpy change of combustion of carbon, which it is 1 mole of carbon burning in oxygen to produce carbon dioxide. Again, कोई hypothetical value दे देते हैं, minus 25 kilojoules per mole. And I can also call it the enthalpy of formation of the same reaction. I can also, its enthalpy change can be called the enthalpy of formation of carbon dioxide, which would have exactly the same value. Because 1 mole of carbon dioxide is formed from its constituent two elements, which are carbon and oxygen. So you can give them you can kind of give them the same exact, different labels can be assigned to the same reaction. एक और कर लेते हैं just to be clear with this.
Sir, what about like sulfur dioxide?
For sulfur dioxide, we can do the same thing. Like this one, sulfur plus oxygen and producing sulfur dioxide.
Yes.
So sulfur is a solid, this one is a gas at room temperature, this one is also a gas. So this one is the enthalpy of combustion of sulfur. And you can also call it the enthalpy change of formation of sulfur dioxide. So you can assign, the enthalpy change could be given two different labels. So I'm going to do one more. Let's talk about this one. How many different labels can I give to this one? Carbon plus oxygen, half O2, producing carbon monoxide. What can I call this reaction? It's enthalpy change. I'm giving names to its enthalpy change. So what can I call this enthalpy change? Can I call it combustion or formation, or can I call it both? And I'll write the states, but states are important. Just a second. Achha, so is on your right. So for this one, I can only call it the enthalpy of formation of carbon monoxide, because 1 mole of carbon monoxide is getting formed from its constituent elements, which are these two elements. Why can I not call it the enthalpy of combustion of carbon? Can I call it the enthalpy of combustion of carbon or not? Exactly, because remember, for combustion, I told you it has to be complete combustion. So carbon burning in oxygen would always produce carbon dioxide. So remember this, carbon monoxide is produced when there is incomplete combustion. By definition, enthalpy of combustion has to be in excess oxygen, so it has to be complete combustion. So over here, the reason I can't call it combustion is because there's incomplete combustion that's going on. So we can't give that label to this. So just remember this, multiple labels can be assigned. And also remember this, that they'll ask you a lot about predicting the signs. So remember this, that combustion is always exothermic, formation can be both. So now we're going to move towards the other definitions. So the other ones are, let's talk about atomization. So the next one, again, the definition, etc., everything has to be memorized. So this is the standard enthalpy change of atomization. So standard enthalpy change of atomization, and its symbol is delta H. Delta H. Sometimes it's the whole atom is written, or just 80 with a knot on top. The knot usually indicates that the conditions are standard conditions. So atomization, what is atomization? Atomization is, now this would be only for elements. It's not for compounds. It's not for molecules. It's for elements only. So it's always endothermic, because you're trying to form bonds, atoms, which is why you would have to break bonds. So it's always endothermic, always positive. So it's the opposite of combustion. Combustion is always exothermic. This one would always be endothermic. So it's always endothermic, and I'll also write that to form atoms, you would have to break bonds, which is endothermic. So only bond breaking happens in this. So what's the definition? The definition is that it's the energy that is needed to form 1 mole of gaseous atoms. From its element in its standard state. So you're trying to, its energy needed to form 1 mole of gaseous atoms from its element in its standard state, measured under standard conditions, obviously. So standard conditions. Just don't, when you actually write the definitions, don't write abbreviated forms. Write the whole complete word. As anyway, so what you're trying to do is you're trying to form 1 mole of atoms from what? From its element, and the element needs to be in its standard state. That's what you're trying to do. And so the first one. So I'm trying to make 1 mole of chlorine atoms, gaseous. So I need to make 1 mole of chlorine atoms from its element. What is the element at room temperature? Chlorine is diatomic, so that is Cl2, and it's gaseous at room temperature. So I want to make 1 mole. This must be 1 mole. So you need to balance it accordingly. So this should be half. To balance it, there should be half Cl2s. And that's it. The enthalpy change of this particular reaction is going to be known as the enthalpy change of atomization of Cl. So whenever you try to make 1 mole of Cl atoms from its elements, that's enthalpy change of atomization. Energy would be needed because you would have to break the Cl-Cl bond. And similarly, you can do this for pretty much any element. Like if I want to make 1 mole of, what's the enthalpy change of atomization of carbon? 1 mole of carbon gaseous atoms need to be formed from its element.
सर ये एक तरह एंथैल्पी चेंज ऑफ फॉर्मेशन भी है ना? लेकिन उसका एक पार्ट है कह लें.
नहीं, this enthalpy change of formation, enthalpy change of formation is usually for molecules and compounds. When you try to make, okay, so in a way, the definition can fit this like it's the enthalpy of formation of a chlorine gaseous atom. Like usually it's enthalpy of formation is for compounds, an actual compound.
Okay.
जैसा HCl की enthalpy of formation होती है, that's a formation. I mean, you're forming a compound, ठीक है, from its element. So it's usually for compounds, ठीक है. मतलब यहाँ पे हम ऐड कर सकते हैं कि 1 mole of a substance है ना, so it's generally a compound. When we talk about a substance, you're talking about a compound.
Okay.
Izan, it's both. वो formation जो था ना, that I told you was sorry, this is wrong. It's not, sorry, I wrote it in the wrong place. यहाँ पे लिखना था. अच्छा, 1 mole of a substance, so I can call it a compound. Because you're always forming something, ठीक है, from its elements. अच्छा, anyways, Izan, enthalpy change of formation could be both positive and negative. Why? Because it involves both things. It involves breaking of bonds. It also involves forming of bonds. For example, if you're forming NH3 from N to NH2, you would have to break the N2 bond and you would have to form the NH3 bonds. So it would depend. If the endo part is bigger, then the overall thing would be endo. If the exo part is bigger, then the overall thing would be exo. So it can be both. So remember that as well. अच्छा वापस इस पे आ जाते हैं कि you've got let's finish this at the moment. So carbon gaseous, 1 mole gaseous carbon atoms formed from its elements, which the element of carbon is usually graphite, which is a solid. So that's it. This change would be enthalpy change of atomization of carbon, and we can do this for lots of substances like oxygen. The enthalpy change of atomization of oxygen, you form 1 mole of gaseous oxygen atoms from its element, which is O2, and that should be gas. Half O2, and it is gas. So this is enthalpy change of atomization of oxygen. I'm going to add, we're running out of time, but I'm going to add one thing to this, and that is that sometimes the enthalpy, wo jo bond energy wali baat nahi thi, sometimes the enthalpy change of atomization can be found using bond energies, because for example, but for bond energies, all the substances must be gaseous. So for example, this one over here, for this, I can definitely, so for this one, I can definitely use bond energies, because the only thing I'm doing is I'm breaking a Cl-Cl bond. That's it. And I'm breaking half of it. I'm breaking half Cl-Cl bond. That's it. So I can use bond energies. It's the bond energy of so it's basically the bond energy of Cl-Cl into half, because there's half molecules, half Cl2. I can't do this for carbon, but I can, because carbon is a solid. Remember, bond energies can't be applied for that. The same goes for oxygen. If I want to find this, so again, this one, people are looking for, okay, I mean, if you need to solve a question and you need the enthalpy of atomization of oxygen, people are trying to search the question, where is the enthalpy of atomization of oxygen? So over here, you can use bond energies, because the only thing you did was you broke the oxygen double bond oxygen. That's it. So it's basically equal to the bond energy of oxygen double bond oxygen. And since it's half a molecule, so that would be multiplied by half. You're just breaking half the molecule, or half moles of the molecule. For carbon, you can't use bond energies for this one. So not always can you use bond energies. For this one, you can't use bond energies because it's a solid. ठीक है, is this clear?
Yes.
चले. अच्छा, that's it. बल्कि एक और point है इसमें कि you must be, I mean, we already covered that if it's a strong bond, then obviously enthalpy of atomization would be very high. Like if there's a triple bond, then obviously a lot of energy would be required. For example, if there's diamond, you would have to break a lot of bonds. So remember, enthalpy of atomization, why would it have a large value? If the bonds are really strong. We did that in bond energy as well. So if the bonds are really strong, then enthalpy of atomization would be very endothermic. If the bonds are really weak, then the enthalpy of atomization is not going to be that endothermic. But it's always going to be endothermic, because you're always trying to break bonds to form atoms. Everyone, let's continue and complete the definitions first. And then there's just 3-4 formulas that we have to do to solve the questions. I mean, solve those past paper questions. So let's talk tomorrow then, okay? At the same time.
Okay, sir.
Okay.
Okay, take care, love.
Sir, कल class है?
हाँ, कल class है, ठीक है?
Same time.
हाँ सेम टाइम, ठीक है।
Okay, sir. Thank you. Allah Hafiz.
अल्लाह हाफिज।